Alright, welcome back. We are in section 6.4, and 6.4 is on common logarithms. So there is a, quite often when you deal with logarithms, you'll deal with the base 10 log. You'll see that all over the place, and it's primarily because we deal in a base 10 number system, so 10 pop up everywhere. So the common log is that, it's basically just a log base 10. So when I have a log with a base of 10 of whatever, typically we just don't even bother writing the 10. A lot of times, like when you see x, that means x to the first power. We don't write the 1 because it's the implied value. When you see a square root without an index, it's an implied 2. In this case, when you have a log without the base written, it's an implied 10. As long as it's an log log. So if I have log of a equals b, this is implied that it's a base 10. And so I should know that simply because it's the common log, right? So common logs are useful when you see things like, for example, that number, 10 million, right, is equal to 10 to the 7. Right? Here we see 10 is a power. It's a common power, especially when you're dealing with things like scientific notation, whatnot. But I can rewrite this equation here in logarithmic form. 10 is my base of the exponential on the right hand side, so I can rewrite it as a log with that base 10, which I don't write because it's the implied base, but it's the log base 10 of this 10 million equals 7. Right? And so you can think of it as being true because if the base is 10, if I rewrite this as an exponential, that's 10 raised to the 7 is this 10 million. That's a true statement. So we can see things, we can evaluate things like, say, what is the log of 10, right? And whenever we see these, we say, well, it's equal to something. I may not know what that is, so I'll call it x. And if I rewrite this as an exponential, I get 10 to the x is equal to 10. And therefore, x has to be 1. Because this 10 is raised to the 1, therefore 10 to the 1 is equal to 10 to the 1. Good. We might also see things like, say, log of 0.000001, perhaps. If I want to evaluate this, then I simply again say this is equal to something. I don't know what it is, but writing it this way, then I can rewrite it as an exponential as 10 raised to the x is equal to this 0.12345 and then 1. Right? But on the right hand side, you'll note that this is 10 to a negative power, and in fact this is just 10 to the negative 1, 2, 3, 4, 5, 6. So that is 10 to the x equals 10 to the negative 6, and therefore x is negative 6. Right? Sometimes we have stuff inside the logs that aren't 10, nice powers of 10. Those nice powers of 10 are 10, 100, 1,000, 10,000, and so on, or 0.1 or 0.01 or 0.001. But sometimes we might have to do something like, say, rewrite the log of 37 equals x. If I want to rewrite this as an exponential, again it's that implied 10 that's not written here, raised to the x equals 37. What is the solution to this? I don't know. It's something ugly, right? What I do know, though, is that 37 is between the first and second power of 10, right? 10 to the 1 is 10, 10 squared is 100. 37 is between those two, so x is 1 point something, somewhere between 1 and 2. I don't know what it is off the top of my head because this type of calculation, not something that goes on easily, right? But we'll get to that. Well, why not right now? Rather than rewriting this as an exponential, right? This is nice that you know how to do this, but it's not particularly helpful because it's hard to take 10 raised to the 1.1 and see how close you are, and we don't want to do that. We can, though, plug in the log of 37 into a calculator. So grab your calculator, find your log button, and just type log of 37. However that happens, some calculators you have to hit 37 and then log, because when you hit log it executes the command. Depending on your calculator, though. So if I take, though, the log of 37, I get somewhere around 1.56. And that number keeps on going. It's 1.568201, yada yada yada. But the important thing is that you can throw this into the calculator. It's 1.56, and like I said, between 1 and 2, right? Which makes sense for 37, right? So let's evaluate a couple of other things. Let's evaluate let's say the log of 2,597, right? We can also walk through and kind of get an idea. I know that this thing should be 2 point something. How do I know that? Because if I say this is equal to, I don't know, something, again it's 10 to the x equals this 2597. So this is indeed helpful to imagine or to picture what's going on. 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000. I think I said 2 point something. I lied 10 seconds ago. It's 3 point something. Because 10 to the 3 is 1,000, which is smaller than this number, but 10 to the 4 is 10,000, which is bigger than this number. So I should get 3 point something out of this. Let's do this. Let's plug log of 2597 in there. And I get 3.4144. So 10 raised to that exponent is equal to 2597. Good. Let's evaluate. Let's do one more here. The log of 0.0032. What do we get here? Now this is valid. I can take the log of anything that's not 0 or negative, so this will be fine. But again, if I think about this as saying, well, this is equal to something, I don't know what, but if I rewrite this whole thing as 10 to the x equals 0.0032, well, x should be negative because we've got this small decimal. But let's look at this. 10 to the negative 1 is 0.1. 10 to the negative 2 is 0.01. 10 to the negative 3, 0.001, right? And then 10 to the negative 4 is 0.0001. This number, 0.0032, is bigger than 0.0001. It's even bigger than 0.001, but it's not bigger than 0.01. So my answer should be somewhere between -2 and -3. So it should be -2 point something. I don't know, somewhere in there. But I can at least get a ballpark figure just by looking at it. So I'm somewhere between -2 and -3. If I plug this into my calculator, what do I get? I get -2.4948, something like that. And again, that number just keeps on going. Most of these numbers are going to be irrational. They're not going to stop, they're not going to repeat. If it's not a nice number in here that's a power of 10, it's not even going to be an integer error. So that's how we evaluate those logs. All right, thank you, and I will see you guys on the next one.